Okay, I led you to believe there'd be a 50-50 portfolio coming up, and that's exactly what we're going to do. So let's see where we've come from. We know that we have a stock fund and a bond fund. We know that the expected returns are 11% and 7%. We know the standard deviation is 14.3 and 8.2. The question is, when you combine them, what is the portfolio expected return and expected standard deviation? We have one for each, but if you move them 50% in, that's going to change both the return and the volatility of your portfolio, of the combined bond stock portfolio. So how do we do that? The first one and the easiest one is the return on the portfolio. Here at the bottom shown is R sub P equals the weight of the bonds times the return of the bonds plus the weight of the stocks multiplied by the return of the stocks. Now easily we could do the recession, which is line, which is negative 7% for stocks. Half of that is 3.5. And the 17%, half of that is 8.5. And negative 3.5 plus 8.5 equals 5% on the portfolio. Negative 3.5 plus 8.5 is positive 5%. So that's the return on the portfolio. Now you could also do it, even easier in your head is you could add 17% minus 7% is 10% divided by 2 is 5%. And if you go to the normal, it's 12 plus 7 is 19 divided by 2 is 9.5, and 28 minus 3 is 25 divided by 2 is 12.5. So you can do it that way too. But we only are concerned with the portfolio. So let's keep going. The expected return of the portfolio is the weight of the bonds expected return plus its expected return, the weight of the stocks and its expected return. So if you take 50% of the 11% of the stocks and 50% of the expected return of the bonds, you get 9%. So half of the 11% is 5.5 and half of the 7% is 3.5, and that adds up to 9%. So the combined portfolio, we're expecting a 9% return on. We get 11 from one, we get 7 from the other, combined at 50%, we should get a 9% return. So that's less than we would have with stocks. So why would we want to include the bonds? Well, here's why. The next step is the variance in the standard deviation. Now, many professors would make you memorize and prove a standard deviation for a 2-item portfolio. It's very common to make you memorize this formula, which is the variance, which is sigma squared. The variance of the portfolio sub P equals the weight of the bonds times the standard deviation of the bonds squared plus the weight of the stocks times the standard deviation of the stocks squared plus 2 times the weight of the bonds times the standard deviation of the bonds times the weight of the stocks times the standard deviation of the stocks multiplied by rho, or the correlation coefficient of the bond stock portfolio. Okay, no, I'm not going to make you do that. Okay, so other people will. If you have a professor who does, just do it. It's simple. It's plug and play. You've got all the information, plug and play. It's no big deal. But I'm not going to make you do that. The answer to that variance question is shown here as 0.001. So 0.001, that's the variance, and that's the sigma squared. To get that, we take the square root of it. So the square root of it, as you can see, is 3.08%. The standard deviation is 3.08% of the combined portfolio. So the combined portfolio has an expected return of 9% and a variation of 3%. So it's very narrowly distributed. Look at the distributions on both sides of it. The distribution of the stock fund is 14.3. The distribution of the bond fund is 8.16. Combined, it's so narrow, it's only 3. How do they do that? They're moving opposite. So the actual combination is moving very small, which is exactly what you want as a shareholder. You want your portfolio to give you steady returns over time. So is it going to be as high as the 11? No. But if you think about this, 9% plus or minus 3% means that 68% of the time I'm going to be within plus 6 to plus 12% of my returns. Well, that sounds great. Now, 2/3 of the time, I'm going to be positive and a 6% return. I'm in. How do I do that? So in these numbers, you would start saying, oh, I'm diversified really adds a lot to my comfort. Yeah, but throwing little bonds in there makes a big difference. I might not get as big a return overall over a long period of time, but boy, can I sleep better because I'm not going to have those big negative years, or not as many of those big negative years. In fact, 2 standard deviations out, that's 95% of the time. If you take an average mean of 9% and 2 standard deviations out, -3, -3, that means 9% minus 6. 95% of the time you'll still get a 3% positive return. That's a pretty good thing to have, right? So this is why diversification is so important, that we look at it and we start saying to ourselves, okay, I can get a little bit less return, but my returns become much narrower and I can sleep so much better knowing that 95% of the time I'm going to get a 3% return, and that's fantastic. So that's why we do correlations and coefficients. Next, that's 50-50. Next, we're going to look at what if we do 60-40, what if we do 70-30, and start looking towards a concept called the efficient frontier.